Hi, very good morning all. Hope you're all doing well. I'm RadhaKrishna Prasad, the trainer of this program. A little bit about myself. I am basically a corporate trainer and a professional trainer who takes care of all the end-to-end performance testing and engineering activities. Right now, I'm working as a site reliability engineer with one of the top 5 companies, and I also give personal trainings, I give corporate trainings, and we give multiple roadmaps to customers on how to do performance testing, what is the approach towards performance engineering, how to set up all the APM tools, what is that they have to do as part of performance testing and engineering when it comes to defining SLAs or defining the performance and all of that. So you might have heard about the previous sessions that I have taken. We have already sessions available for garbage collection tuning, and also heat dump analysis. This is the third session that we are taking it as a free session on thread dump analysis on behalf of PerfMatrix. So thanks to Gagan for conducting all the sessions, and thanks to all of you for joining, first of all. And yeah, so before I start, so basically, there are multiple questions that many of us have, like what is that we have to do in performance testing? What is that we have to do in performance engineering? And what is that we have to do as part of bottlenecks identification with respect to multiple APM tools, okay? Like be it AppDynamics, Dynatrace, CAPM, New Relic, Prometheus, Zabbix, okay, etc., etc. You have a lot many things. So the question is, what is that we really do in performance engineering? As part of performance engineering, what are all the core activities that we have to do? So from traditional performance testing to the recent emerging performance testing trends that we have in performance engineering, okay, so you have to get familiar with some of the concepts like operating systems. Then you have to get some familiarity with the network protocols. Then you should get some good understanding on web servers, app servers, application servers, network protocols, and you also need to gain some good experience on all the databases along with multiple APM tools. Okay, so but in common, from 1 year experience to 15 years experience, many of the people, what they commonly miss is they miss to do some of the key activities. Like the most commonly performed activities are heap dump analysis, then thread dump analysis, and GC log analysis. Okay, these are the core concepts of any application. I mean, analyzing the heap dump to understand what are the different problems that you get from the memory side, and analyzing the problems from the thread side, which talks about thread dump analysis, and something called GC log analysis to understand what percentage of uh, unreferenced objects are getting deleted in a timely manner when the test is being executed with n number of users concurrently, parallelly, simultaneously, anything. Okay, so today we are going to cover one of the main important concepts, especially the thread dump analysis. As this session is, it will take so much of time to explain each and every concept. So we will keep this short, and we have identified what is required for you as part of this session. Okay, for a performance engineer, what percentage of concepts are required from a thread dump analysis? What is basically the basics of thread? What is thread dump analysis, how to take thread dump analysis, all these things we have identified, and we'll help you with all of this things that you are currently seeing on the screen. Okay, so we're going to tell you what is thread dump, the different ways of taking thread dump analysis, and how you can take thread dumps with various tools available with Java JDK or other tools. So what are the problems that you have to identify? What is the remedy? What is the fixes that you have to do? There are some tips and tricks available for eliminating all such bottlenecks. So all these things will be explained as part of this session, okay? And also you have thread life cycle, and there are few thread dump analysis techniques. So this session would tell you at least some 50 to 60% of the things that you need, and you can successfully do that in your real-time assignment when you work in any performance testing assignment. Okay, and coming to the questionnaire session. After this session, we'll have the questionnaire. We can take up all the questions and we can answer all of them at the end of the session. So we'll start. Okay. So today we're going to cover all these things as I have shown you. Now, when it comes to performance bottlenecks, right, there is something called always performance bottlenecks. Especially, this is some basics that I would like to show you on what is that we have to do as part of thread dump analysis. You need to understand what is thread dump analysis. You need to understand the basics of threads. You need to understand why you have to take thread dump and when is the best time to take the thread dump. And the most important point is how many times do you need to take a thread dump in a test that you execute. Okay. And coming to the tools, there are various number of tools available in the market depending upon the feasibility, depending upon the customer that you work. If you have BFSA clients in a restricted ODC, you may not have exposure to use like all the online thread dump or heap dump analyzers like heaphero.io, fastthread.io, or Spotify heap dump analyzer or JStack review analyzer. You cannot open anything like the way you will open in the browser in other projects, right? So what you have to do is, whenever you get any performance degradations, any Java-based application, when it is running much slower than expected, you need to take thread dumps. The answer is simple. Okay. So whenever your application is having high response times, you have high resource utilizations, you have other degraded performance from the application server, it is the time we have to take multiple thread dumps and you have to start analyzing them. So as a beginner, if you don't have access to the servers and if you're still working as a performance tester, not as an engineer, you need to start from the page number 1. Thread dumps, basically, you will feel like very complicated at the very first time, but I'll explain you in a way that what are threads in Java, what are the types, how they are. I will not tell you how they are created because that is something which will happen from the development side, and managing them. So how you can dump threads from a running application is what I'm going to tell you. And finally, I'm going to explain you how you can analyze them and identify the bottlenecks of all the blocking threads. Okay, so if I start with some of the basics, right? Can anyone tell me what is Java thread? What is the use of thread? A web server or application server uses tens and hundreds of threads to process large number of concurrent users, right? I'm audible, right? I doubt if I'm not audible. I'm audible, right?
Yes.
Yeah.
Okay, thanks for the confirmation. So Java thread, when I say any thread, right, any web server or application server, they use tens and hundreds and sometimes so many threads. They use threads because to process a large number of concurrent users, right? For example, if you have a Java application, if you have 2 or more threads, if 2 or more threads are utilizing the same resources, what is going to happen?
Deadlock.
Contention, right? Contentions between the thread will happen, and sometimes deadlock will happen. So, do you know what is thread contention? Because we would like to go with some of the basics. I'll tell you what is thread contention. What is thread contention? Fine. So
Insufficient threads.
I mean, yep. Basically, thread contention is a status where one thread is waiting for a lock held by another thread, and this thread is waiting for the first thread to lift that particular lock on that object. So different threads, basically what they do is they frequently access shared resources, and contention between threads is something that is going to happen. Okay. different threads, they are going to access shared resources on a web application. For example, to record a log, the thread is trying to record the log. It must obtain a log and access the shared resources. If a thread has to do something in the application, it has to obtain a log on a specific object, and it will access all the shared resources, and it will process everything. Okay. Now, what is the meaning of deadlock? Or if I ask you, how do you identify deadlocks in any web application, in any Java-based application? There is a question, right? How do you identify deadlock while doing performance testing? Your immediate question that you have to ask the interviewer was, I'm sorry, are you referring to the deadlock that is happening from the application server or database server? Because deadlocks happen from both app tier and database tier. So to identify the deadlocks on application server, the only option that is available is taking a thread dump. Thread dump is something which is going to tell you where is the deadlock and how the deadlock has happened. Okay, deadlock is a special type of thread contention in which two or more threads are waiting for other threads to complete their own tasks. Okay, so I'll show you a practical example that we have a sample program that is available in Eclipse IDE. I'll show you how a deadlock will happen, and different issues will arise from thread contention. So to analyze such type of all the problems, you need to take thread dump. I'll tell you how many thread dumps do I need to take if you're running a test for 1 hour, if you're running a test for multiple hours, for example, 4 hours or 8 hours. It is always a question, how many times, how many dumps do I need to take? So a thread dump will basically give you the complete information on the exact status of each thread is doing. Okay. So basically, when I'm referring to Java thread again, thread will allow a program to operate more efficiently by doing multiple things at the same time. It is not one single thread. The concept of multi-threading has been incorporated in a technology like Java or .NET to do things simultaneously. Threads can be used to perform complicated tasks in the background without interrupting the main program. And also when it comes to concurrency, right? In order to achieve the high efficiency and performance of the application, we have to achieve something called concurrency, and this concurrency will be achieved by something called multi-threading concept, right? Because threads, all the threads, if you have 10 threads will run at the same time like other parts of the program, and there is no way to know in which order the code is running, which thread is doing what. We cannot identify that. So when threads and main program are reading and writing the same variables, the values and results are unpredictable. So the problems that we get with respect to concurrency or with respect to threads are unpredictable, and only during the performance testing assignment, when we are testing with multiple users with different anticipated load conditions, we'll get to know the application behavior, application code behavior, application server behavior, along with the other components that are part of your infrastructure and architecture. Okay. Now, can you tell me what is thread dump? What does a thread dump contain?
So it would have the information of like how threads are processing the applications or processing the task.
So let me tell you one thing. The heap dump, right? Heap dump is all about the objects. Each object is doing what? How much memory is occupied by every single object that is part of your application code is what you're trying to analyze in heap dump. Whereas in thread dump, you're trying to get the complete snapshot of every thread that is part of your application or in a program that is executing your application code. So some of the threads, they belong to our Java application. There are different types of threads, daemon threads and non-daemon threads. For example, JVM, you know JVM, right? Java Virtual Machine, Java JVM. For .NET, it has CLR, Common Language Runtime, which is a runtime engine which is going to take all the application source code, it compiles the code, it converts the code, and it runs the code, it executes the code, and it will create some threads to do all the simultaneous concurrent activity on the application. For example, if you take all the threads, right, there are some threads which are called internal threads that are created by the JVM itself. There are some threads that we create while creating the program. Okay, so all these things are managed by application server. For example, you are running out of threads, you are getting high response times, you are getting different performance problems from the application when you're doing performance testing. What do? There is something called thread pool size, which will set it to 50 or 100. You're increasing the thread pool size, right? You want to increase the thread pool size, and you want to go with, you have to configure that in a server like WebLogic. For example, here, just a minute. You're able to see my screen because I'm there in a VM. So I'm starting my WebLogic server here, which is installed on my VM. So in order to increase thread pool size, in order to take thread dump, in order to see what is the stuck thread count or the values that are set, right, you can directly go to the WebLogic server. Not only WebLogic server, if your application server is WebSphere server, if it is WebLogic server, if it is something else like Apache Tomcat server, you can go to the appropriate config file and you can look for the changes that you want to do as part of thread pool size. Okay, so when it comes to thread, again, a thread is the smallest unit of execution, and every thread that you create, or which is created by JVM as an internal thread, a thread allows multiple tasks to execute concurrently in an application. Okay, for example, there is a difference between a single thread and multiple thread. If you have a client application which is receiving a request, for example, you're trying to get some information, you send a request to the server, right? And so if you consider a client application which is receiving a request from a server for a processing, or sending some messages to the database server, or writing some log files to the database, or files in the database server, if it is a single threaded, then it cannot receive another request while it is sending a message or writing something to the database. This is not the expected behavior, right? You are sending a request, and that request is doing something on the database. It is writing something to the database, or it is fetching something from the database, or it is writing something to a file inside the database. So if it is a single threaded, until and unless that particular task is completed, it cannot handle another task. This is not desirable. So with multi-threading concepts, where you are introducing multiple threads, okay, where each new thread is sent for each server request. So what it does is every request that is sent will be individually taken care by the multiple threads that are available, and when multiple threads are executing in parallel, this is called concurrent execution, or concurrent programming, or concurrency. Okay, my main spotlight word is concurrent. We might use different terminology, but that is something that we have to understand. Now, if I ask you, when is the best time to take something called thread dump analysis? Okay, there are thread problems, right? What are the thread problems? Each time people come to us and say that we are continuously experiencing high CPU utilization. Why?
So waiting of the clock.
You're saying what? Sorry?
In threads are blocked for some waiting for other process, right? So the thread comes will keep increasing. Because it will CPU reception.
So basically, what will happen, right, when you do performance testing on any performance testing environment or any production environment, the app server will automatically freeze, and it can bring down the entire application server in production environment or your dedicated performance testing environment. Okay, or if your app server is unresponsive, okay, you have to understand what went wrong and why it went wrong, and you have to take a thread dump. So thread dump, right? So in the event of app server crash, or if your uh, app server hangs, you have to take a thread dump. Any other reasons you have? Because people try to understand what are all the situations you will take a thread dump.
This also needs to get me time of the
My question: what do you do when your CPU utilization is 100% in the middle of performance test execution? You understood my question, right? What do you do if your CPU utilization is 100% utilized at 65th minute of your test, when you're running the test for 120 minutes as your steady state? In the 70th minute to 74th minute, if your application server CPU utilization is 100%, what is that you do?
Reducing the parallel connections.
That is one thing, and yes.
Yeah, that's what I wanted to tell. Yeah.
Okay. So you mean to say something like high load, CPU 100% utilized? Then most of the times, right, the GC will not respond. This is called GC trashing, because whatever the GC garbage collection that is running in your application server, that is being taken care by the JVM internal thread. GC is also a thread inside your application server. Whatever the minor GC, major GC or full GC that is happening, it is happening via thread in the application server. But it's not that is not an application thread. That is a thread which is running in the background, which is taken care by Java JVM, Java Virtual Machine. Okay. So in case of GC thrashing, GC not responding, the GC is not happening as expected, that is when you have to take thread dump. And all the time you say slow performance. When they say slow performance, right, do you think this is something with respect to high response times? Yes, there are few transactions which would take high response times. The application would be very, very slow. And if you have some applications, right, you will not only have the web server, application server, and database server. You are going to have API calls in every environment. So you will have serious performance problems with API calls. Okay, these are all the things that are going to happen only from the web application server alone. When people ask you what are the bottlenecks that you identified from the web layer, app layer, and database layer, many of the associates, when we take interviews, are not specific to the problems that they have identified. Okay, when you run a test, when you have access to the application server, the type of bottlenecks that you see are different. And when you focus mainly on database server, the bottlenecks that you see from the database server are entirely different. Let's say if you're targeting to understand all the performance problems from the web layer, you are worried about all the HTTP calls that are happening on the web server. if you want to know the bottlenecks on the application server, you are worried about the methods, the functions, the methods that are invoked, the functions that are triggered, the objects, then the threads. All this information is what you're trying to understand from the application layer. By taking heap dump analysis, multiple thread dump analysis, then you monitor the GC, you take GC logs, analyze them, you work around all the application server. Now the database identification is different, right? So you have to take multiple AWR reports, then which is automatic workload repository if it is an Oracle database. Then you have to take ASH report, active session history report. Then you have to take ADDM report, automatic database diagnostic monitor, to understand the missing indexes, to find out the long-running queries, the long-running stored procedures, inefficient schemas, the table designs. All these things comes into picture only when you are continuously monitoring layer to layer, tier to tier, and doing a deep dive analysis on specific layer. As of now, thread problems, thread dump analysis is specific to application server. So you're going to have all these top 8 problems for any application when you are trying to do some performance testing. Okay, and I can also tell you something like hung threads. Okay, so there are different states of threads. For that, you have to look for hung threads which are creating so many problems in the application for degraded performance. Okay, and also the application server, I don't want to tell you all these things, even .NET application, right? That is the in-depth concepts of advanced performance engineering. In a .NET application, right, you will have a soft hang and hard hang. Okay, if an application server is hanged, IAS server is hanged, for example, your ASP.NET application is deployed on IAS server, which is connected to some SQL Server database, you will have application server hang. And for that, you need to identify what type of hang happened with the application server. Okay, there are different types of hangs again. Soft hang and hard hang are there for application server. Soft hang is something which is happening because of the ASP.NET code issue. Okay, that is related to coding part. Hard hang is something which is the problem with IAS server itself. So you also need to understand the type of hang, the server hang that happened, and you need to identify which type of hang it is. Is it a hang that happened because of the source code that is deployed on the application server, or it is the direct hang that happened because of the application server itself? It can be just because of WebLogic server. It can be just because of the source code that is deployed on the WebLogic server. So you need to identify that type of hang, and you have to accordingly take a call to fine tune the right place, and you have to improve the performance. Okay, and people also say server restarts. So many of the people, as you don't have access to the database and application server, I have seen many people, especially working with BFSA domain, they don't get access to application server and database server, and that is why the reason they don't get opportunity to take heap dumps, thread dumps, AWR reports and all. So when you are running a test for 1 hour, for example, with 200 users, there is a different pattern that you're seeing in the response times and also the error rate. You have a pattern, a zigzag or sawtooth pattern. If you notice it, the application server is continuously restarting. Okay, each time it restarts, when it is up and running, the transactions will pass. For whatever the time it goes down in any environment, the application transactions will fail. So to understand that pattern, you have to go to the application server, and there is a metric called application restarts from the application server, which will tell you how many times the application server has restarted if you are running a test for the last 1 hour or 2 hours. Okay, so and also the deployment problems is what you also see. The deployments are after the application deployment. If your application server is becoming very slow, then simple thing is you will restart it. When you restart it, it will work fine for the first 5 minutes, and again it will continue the same way for the next 55 minutes. So you cannot restart the application server for multiple times, right? For that reason, you have to identify what is the problem. These are all the different performance bottlenecks that are required to take thread dump analysis. If the question is like when to take thread dump analysis, we have to take thread dump analysis when all these issues arise, right? Now, also there is we'll go to the practicals as well. There is always a question that is asked, right? Running vUser as a thread and running vUser as a process. You know what is the main difference? Process, basically, it is the most major and separate unit of execution that will be recognized by the operating system itself. It will be treated as process. If you go back and recollect your Internet Explorer 6 or 7, I don't remember the version of the Internet Explorer, okay, some 8 years, 9 years back, when you open Gmail, it opens as a process in Internet Explorer, okay? Then if you want to open Drive, it will open another Internet Explorer instance, which is a process again. Likewise, each instance that you open in the older versions of IE will be recognized as a separate unit of execution by the OS, and it will be treated as process. But if you take the same Google Chrome now, if you simply click on this tab, this is thread. This is a thread. So these are all threads. A thread, basically it is a subdivision that shares the memory space of its parent process. Google Chrome is a process, and under that you have multiple threads. Each thread is going to have its own private stack, and it will have its own registries, and it will have its own program counters to see that. So for example, now if we go to commands, I have a jar file, okay? Jar file, let's assume that as an example. So jar file, let's assume that as an sample application. Any jar file is an application, right? So I'm passing some arguments like this: minimum, maximum heap, then perm size, then -jar, and this is the location of where my jar file is located. So when I try to invoke this jar file, so it will open the jar file. So you can see a minimum activity on this application. So we'll see that it's a simple one, because on the local machines that you have with 4 GB, 8 GB, i5, i7, do not load your local hosts, personal laptops. So the first way of taking heap dump, I'll tell you. So if you go here, I'll go to Java JDK. The first way that I would take is in the bin, I will take JVisual. So the simple way of taking the thread dump, I'll tell you. So do you see this ensemble app? And you can also see the process ID. If you want to know the process ID with command prompt, you can simply say JPS or JPS-L. So if you see this one, JPS-L will list on all the Java applications that are running with the application names and process IDs. Now I am running this jar file, which is ensemble jar file. Okay. So if you see the name ensemble.jar file, now when you open JVisual VM, so ensemble app, you see the process ID, right? So if you go to the JVisual VM, or if you go to the Visual VM, right, under one in the warrior section, you can see the process ID. You can see the JVM arguments that I have passed, right? 24 MB minimum heap, maximum heap. So then you can look at the monitoring activity. So you can see the CPU activity, the GC activity, the heap statistics here. Now you can see the threads part. So you have two different types of threads. One is daemon threads and one is non-daemon threads. Okay, so you can see the daemon threads as 17 and you can see the live threads as 21. The total threads that are started as 32. Okay, if you want to take with heap dump, you can directly take it from here. Whereas when you come here, you can see all the threads that are running. You can see the time it takes. You can see when it is running, what's happening. You can filter the threads by live threads and finished threads. And I basically select all threads. And when you say thread dump, it is going to take a thread dump. And you can do sampling of the CPU, memory, and all of that. JConsole plugin. So if you go to plugins, right, in JVisual VM, if you go to the available plugins, you can use all the tracers. You can use Visual VM thread inspectors. You can, for example, if I want to use thread inspector, then if you click on install, right, it is going to install that plugin. So basically, whenever you want to inspect some threads when the application is running with the help of thread inspector, you can do that with the help of JVisual VM. So likewise, I have installed a plugin called Visual GC, which is going to give you the complete information of how the utilizations are happening. This is all with respect to heap. We are not talking about that anyhow. Now I'll simply click on thread dump. Okay, when I click on thread dump, do you see this thread dump? Either you can save this thread dump, you can simply save as, okay, you can give the name, or you can simply copy all this raw file. You can simply copy this raw file and you can simply go to sorry, my keyboard is bad. So you can upload a raw file. When you save this one, right? If you want to save this one, you can directly save this file. I would say 02. I'll say like this, and you can go to this one. You can choose the file, and you can go to this one. Okay, you can directly upload the file, and you can click on analyze. That is one way of analyzing the thread dump. Okay, so the other way of analyzing the thread dump is you can directly go to the raw file, and you can just copy paste the complete information, and you can click on analyze. So this is an open tool that is available for everyone, which will help us to tell what's happening with each of the threads, daemon threads and non-daemon threads, everything. Okay, so but the question is, if you take a thread dump, right, what is that you mainly look for? You have taken a thread dump. What is that you look for? Any answer from you? You have taken a thread dump. You analyzed it.
So any stuck threads kind of thing, any deadlocks kind of thing.
You have
of
to,
threads, thread stats.
Status of the thread.
status of the thread. You have a thread life cycle. You have status of the thread. Then you will be able to understand which threads are running, which threads, the thread status, which threads are waiting, which threads are blocked, right? So this is JVisual VM is one point. Okay, we'll come to the thread analysis part. Now, let me go here. So there is one application, one sample program that I configured with Eclipse IDE. Okay, a sample deadlock program is available in Eclipse IDE. Everyone can get that. That is available in the internet. So what I did is I have configured my Eclipse IDE with JProfiler. Okay. So now what I'm doing is I'll simply click on profile as, and I'll simply say profile as Java application. Because the reason why JProfiler is opening, because it is already configured with my Eclipse IDE program. Now, if you see, the memory utilization, the GC activity, classes unloaded. The main worry is about threads here. Now, if I see here, the running threads are 0, blocked threads are 0, waiting threads are 5. Now, if you see here, one thread is blocked, right? Then if you come here, 2 threads are blocked. Then if you total number of threads are 5, then you have 3 threads blocked and 3 waiting threads. Now, there are total 6 number of threads. Now, if you see, there are 2 threads that are going into different states, which are into running, which are into waiting, which are into blocked. Now tell me which thread I need to look for when I take a thread dump, right? What is the first state that I have to look for?
Block thread.
Yes, and the next one is?
Waiting thread.
Yes, the only 2 things are blocked thread, because it is going to block entirely everything and it is going to give you a deadlock. Waiting thread, it is being locked by something else and it is not moving from there. Then running thread is also a problem. You know why? If the thread is continuously running without an exit, you know what will happen?
Contention.
Yeah, other thread will be in waiting only.
The other thread will be in waiting, and when the thread is continuously running, it will utilize more and more number of resources, and it will be the primary reason for high CPU utilization. So a thread should not continuously run. A thread has different states. It has a new state, then it has to run, it has to sleep, it has to park, it has to wait. If in case it has to get blocked, or as soon as it completes its tasks, it has to exit or it has to get terminated. That is the life cycle of a thread, basically. So the reason why I connected this program is, in order to understand the deadlock, you have monitors and log section. Under that, you're going to get the information of the current locking graph. Which thread has locked, obtain a lock on which object is what you can see in red color here. Some thread 5 has obtained a lock and locked that particular object. So when a specific thread is obtaining a lock on a specific object, as soon as it finishes its task, it has to release a lock on that object, and it has to make that object available for the next thread. It might be confusing, but I'll tell you. You have a thread 1, okay? Then you have an object 1. Okay, then you have a thread 2, then you have an object 2. So a thread 1 comes into the application. If it wants to perform some task with object 1, it has to obtain a lock on object 1, and it has to complete its task, and it has to release that lock on that object 1 as soon as the thread 1 finishes its task, right? So then when as soon as the work is finished of thread 1 with the object 1, as soon as it releases its lock, the object 1 now will become available for thread 2. Now the thread 2 can obtain a lock on object 1, and it can process its task, and it can again release the lock, and it can make the object 1 for the remaining consecutive threads like thread 3, thread 4, thread 5, etc., etc. Whereas if in a scenario like a thread 1 is obtaining a lock on object 1, the thread 1 now have completed its task with object 1. Now it did not release a lock on the object 1. So the remaining threads will be waiting for the availability of the object 1. When multiple threads like that are obtaining locks and locking the objects, that is when the deadlock is going to happen. So each of the object that is there inside your application has to be available for all the threads that are part of your application execution, application source code execution. So if someone is asking you how to identify which thread has obtained a lock on which object, this current locking graph is something which is going to give you a diagram like this. for your understanding. And you can also see the thread, the duration, the monitor class, waiting thread, and you can see all this information and locking history graph. If you want to record the monitor events, you can also do that. You can look for the monitor history. You can check for the monitor usage statistics. All these options can be enabled, but the main problem of this profiling tool, having a profiling tool directly on the application server, is it will have an extra memory overhead. If your application server RAM is only 16 GB, and if you are enabling all the options from the profiling tool, it will consume more and more resources from the application server. So that there will be no enough memory available for the application, and very soon it will run out of memory. You will get out of memory error or something. With for minimum number of users, when you are testing, you will see high memory utilization just because it is utilizing all the resources. So the disadvantages of using the profiling tool on the same application server is to have excess number of resources. So you need to check that you are having enough resources when you do this thing. Okay, so if you go to threads, right, you can also take thread dump from here. If I say that take thread dump, then I can take another thread dump. You can take multiple thread dumps here. Okay, so you can these are all the thread dumps. So you can compare through two thread dumps. Okay, it is going to give you the information like this. So what each thread is doing, you can find the comparison. As this is a simple sample program, it is taking so much of time. Let's not go this way, or this is a sample program, so we'll directly go with the demo program. Okay, so if you go to JProfiler, in the JProfiler, you have this profiling tool available with demo servers installed. If I click on JDBC demo, then you have some settings here to configure. When you do that, it is going to ask start database activity. As this is a demo server that is already there, that has come with the JProfiler, I would say leak connections. So I'm asking my JProfiler tool to simulate leak connections, and I'm starting my database activity. Now, if you see here, you can see whenever a GC is happening, there is a memory that got freed up. Then you have threads that are waiting, that are blocked. You can see all of that. You can also see the CPU load. One is process load and one is system load. If you see the system load, you can see that system load, which has gone so high at some point of time, approximately 47.66. Then you see another spike of 51.75, right? So if you see all of that, now in the threads part, I would take a thread dump again. So then I would like to take, let's give another 10 seconds. Okay, so I would take another 10 seconds. So you can compare these two things. Actually, the differences will be highlighted. So you can see what happened between two different identical thread dumps that are taken in 10 seconds time gap, right? So you can see all that, and I'll tell you the analysis part, don't worry, but this is one way of doing it. Okay, so this is with the JProfiler. JVisual VM is done, right? So if you now go to, there is another utility in the same Java JDK bin. If that jar file is running, yes, that jar file is running. So what we are doing is we are going to go with JMC, which is Java Mission Control. So if you see here, this ensemble.jar file is something which is there, right? So if you open this flight recorder, open this flight recorder, I would right click on it, sorry. I'm starting my console here. Initially, I'll start my console to see you are getting a statistics like this historical data. You can see the dashboards. You can also add something like this. Okay, for example, if you want to see the used memory of heap, you can also add this one. You will get another one here. You can add multiple meters in the dashboard. You can see the processor utilization, memory utilization, the way it is happening. Now, if you come to the threads part, it is going to give you the information of all the threads, okay? The threads that are currently part of your application that is running. If you want to know each thread state, the blocked count, the thread name of that is part of your application execution. If you want to know the CPU usage of each thread, you can simply click on CPU profiling. If you want to see now the total CPU usage for every thread is what you can see, right? For example, this thread which is running is approximately having 1.04 total CPU usage. Now you can see the CPU utilization by numbers here. 0.86 this particular thread is utilizing. Okay, now if you click on deadlock detection, it is going to give you the information of deadlock. Whenever you see a word called yes in the deadlock, there is a deadlock. It will give you yes, no with that particular thread. You can easily identify the thread. Okay, when it comes to allocation part, I'm sorry. When it comes to allocation part, you can see the allocated bytes of each thread with respect to the memory, the thread state. You can see the blocked threads. There are no blocked threads. There are running threads, there are waiting threads, there are timed waiting threads, and you can see the blocked count, and you can see also the CPU usage along with the deadlock. Okay, basically this is the current statistics of your threads that are there in your application. But if for example, if your test is running, now what I'm doing is I am clicking on start flight recording. When I click on start flight recording, it has to ask for so many options, but I don't want to do all of that because this is a commercial one. Whichever the JDK that is available, if you want to enable all the features with the JMC, you need to buy a license for that. So I am just recording it for 1 minute with with the time that is available for me. So you can see, you can enable everything to true so that Java application statistics, for example, if you want to have the class loading statistics, you have to enable this. If you want to get this information in this recording, you have to enable this. So you have to, if you want to get the Java thread statistics, you have to enable this to true. If this is set to false, right, you can, if you click on uncheck this one, it will become false. It will not capture the Java thread statistics. So likewise, you have multiple options here under Java applications. It is up to you from JVM what is that you will need, from GC, from heap summary. If you want, you have to enable it. If you want to have metaspace, you have to enable it. Then once you click on finish write, it will record for a minute. It will record for a minute. So in this 1 minute, it will automatic. I mean, there is a setting. Basically, that setting is not seen in this version of Java JDK, but there is a setting for which interval you have to take that thread dump, for how many seconds, for what interval you have to take thread dump. I have set for every 10 seconds. Okay, so basically, if you talk about any threads in the application, right, thread dump snapshot, if I'm referring to any thread dump snapshot, some threads in the application will be performing raw computing tasks like XML parsing, IO disk access, etc., etc. Some threads could be waiting for some blocking IO calls, such as remote web service calls, a database connection, a JDBC query, etc., etc. Okay, there could be some other threads which could be involved in dedicated garbage collection, and these are called the threads which are taking care of garbage collection. They are called GC threads. Okay, and there are some threads which will be continuously waiting for some work to do. Those threads, they don't do any work. They typically go in a wait state. Okay, So like I explained you one of the example just now, some threads could be waiting for some other threads work to complete. That threads wait to acquire a monitor lock on a specific object. Like I said, the thread one has to release an obtain a lock to process some activity with that object. After finishing that activity with that object, it has to release that object. It has to take that lock out. Only then the thread 2 will come in and it will obtain a lock again on that object one, and it will complete its task. So now if you see here, there are so much of information here, right? So there is a memory tab, there is a code tab. If you go to threads, this is the information of the threads. So the main advantage of looking the information from the thread side in thread dump analysis, basically, you can see the thread count, right? You can see the thread count, you can see the daemon threads, you can see the active threads, you can see all these things, right? And also you can see the CPU usage here. When it comes to hot threads, right, you can see the hot threads, the threads by Java thread ID, the operating system thread ID, sample count. You have to understand two things. When you take a thread dump, right, I'll show you. Sorry if I'm taking so much of your time. When you analyze the thread dump, if you see the thread dump here, so if you see the initial information of any thread, you can see the thread name. I'll tell you, you can see the thread name. Then you can see the priority of the thread. This is nothing but the thread ID. Okay, NID is the native thread ID, NID. So you can also see the status of particular thread. Okay, it is waiting on condition. Okay, and this thread is running. Do you see this one? This thread is running. This thread is waiting on condition. So you can also see java.lang.thread state waiting, which is in parking state, and parking to wait for this one. Okay. And if you see this thread is running, this thread is waiting, you have the thread priority, the thread name, the OS priority, thread ID, and NID. And there are two threads available again. There are application threads, there are native threads. Native threads are nothing but the threads which are managed directly by the operating system itself. If you see here, that is what is the OS thread ID. Java thread ID is application thread. And OS thread ID, you can see a different thread ID, sample count percentage. And if you want to look for the contention among the threads, there is no contention in this thread dump. Basically, you can see when there is a contention, right, you can see the top blocking locks, top blocking threads, and top blocking threads. You can filter it by count, you can filter it by average, you can filter it by longest. All these things is what you can see. And many of the applications, right, you also get to see latency problems. When you have high response times, right, you also need to take a deep dive analysis on the latency part. You need to understand that problem happened because of any particular thread, or it could be because of any latency. Now, if you see, these are the thread dumps. So by default, the reason why you are seeing 5 thread dumps is because I have recorded it for one minute, and by default it is selected take thread dump for every 60 seconds, 1 minute. That is why the reason in 60 seconds, at the first second it did not take any thread dump. 10, 20, 30, 40, 50, 60 it has taken. Okay, so you can take all these multiple thread dumps here. Okay, and you can also see the lock instances. This is one beautiful way of getting all the information using Java Mission Control. You have to go to the application server, then you have to go to Java JDK bin folder, access JMC, and you can do that. Okay, so there is also utility called JProfiler you have taken, JVisual VM you have taken, JMC you have taken. You can use JStack-L. If you want to take, I don't have a Linux machine now. If you want to take thread dump, you have to use skill -3. process ID to take thread dump. Okay, you can use JSTAG and you can use JCMD. There is a pattern. These are other ways of taking heap thread dumps. And I'm telling you, you can also take thread dump with APM tools. With the Dynatrace, with the App Dynamics, you can take thread dumps. And also, like I said, I'm just closing this one. Like I said, if you have a WebLogic server, right, you can also look at the stats of the WebLogic server. Okay. Just a minute, please. So what I'm saying is, I am starting the WebLogic server. I would like to show you something that some parameter where the parameters are set. Okay. So and coming to the thread dump part, right? So you have top commands, you have kill -3, you have some different commands that you can take. So basically, the information that you always see whenever you try to take a thread dump, the first information that you have to see is the thread name. Okay, like I have shown you just now, thread name is something which is okay. So you can see the thread name here. Okay, thread name is often used by all the middleware vendors to identify the thread ID along with its associated thread pool name and state. That is what I have shown you just now. You can see the thread ID, you can see the priority, you can see the type of thread, you can see the thread name. So thread type and priority, you can see daemon priority equal to 3 or priority equal to 1, priority equal to 0. So basically, threads as daemon meaning threads are running in the background. Daemon threads are which runs in the background. There are other threads called non-daemon threads, which are user threads. Okay, daemon threads, the threads which are running GC, right? All of them are they run in the background and they are called daemon threads. Okay, so if you can see the Java thread ID, this is obtained via java.lang.thread get ID. When you implement something in the system when you develop it, and native thread ID, this is very important. So basically, whenever you get problems with the application, the problems can be because of the application threads or the operating system threads. So native thread ID allows us to correlate which threads from operating system are using the most CPU inside the JVM. Okay, there are certain threads from the operating system which can eat all your JVM's memory. With the help of native thread ID, you can use that. You can identify which threads, which operating threads from the JVM are consuming highest memory. Okay. Now you have seen a lot of thread dumps. Now when I analyze it, okay. Now this is a thread dump, right? Okay. One last important thing before I close the session in the last 10 minutes. So the thread count summary, you can see the total number of threads that are running. You have some waiting threads. Then you have something called stack trace. Can anyone tell me what is stack trace? Or I have a different, let us put the question in a different way. If I take a thread dump, will it create some unnecessary overhead on the application server? I'm taking 5 to 6 thread dumps. If I take a thread dump continuously in a minute for 6 times, are there any side effects?
Yes.
There are side effects. Basically, each application server instance in Java program will be running on the operating system. Okay, and every application server Java program is a multi-threaded program. So it all of the, I mean, that program which is running on the application servers, it loads the code, runs the code, application written by the developers, and some problems are like the server, the application server where you are trying to take multiple thread dumps might get overloaded. It might consume so many resources. When you take a thread dump, right, the JVM can momentarily pass to dump all the stack information. For whatever the time the dump is taken, the JVM will pass for that particular period of time. This doesn't mean that the JVM will go down or the JVM is interrupted, but there is some little effect when you take a thread dump on the JVM. That is called a momentary pass. Okay, so it is extremely a rare possibility that is something that will happen to JVM, like getting aborted or like going down. But in practices, most of the cases that do not happen. So I have already explained you how to take a thread dump, right? How many thread dumps do you need is a question. For example, you are running a test for 1 hour or 2 hours. How many thread dumps do you need to take, and when is the best time to take that?
So we can take a approx 10 thread dump.
You must always take at least 3 dumps within 10 to 20 seconds interval. Why? You know the reason why? Why I have to take 3 thread dumps with a minimum of 10 to 20 seconds interval? This is how, where I can verify if a thread is really stuck. For example, if a thread is, I can identify a thread which is stuck in all the 3 terms executing the same line of code, then that is a direct catch of the problem. So you have to ensure that you are creating 3 different thread dumps. You don't overwrite and you don't overwrite the same thread dump again and again. Okay, so whenever you take a thread dump, you have information like this. You have most used methods. Okay, then you have CPU threads, you have GC threads, you have stack length and deadlocks, right? There is no deadlock found. That's the reason you're seeing here. You can see the exceptions. The most important part of any thread dump is, let's put a question like this. How do you need to look? What are all the aspects that you need to worry about in a thread dump? You got the thread dump now. The question is now what do we do with it? Most of us don't have a clue on what to look in a thread dump, and quite honestly, no one is to be blamed, because I don't say that most of the information that you see in thread dump is useless. So the information that a performance engineer would need is very, very less. He or she has to have some good experience with little concepts in Java, so that thread dump will have 90% useless data. However, with practice, you can quickly directly go to the problem statement and you can identify what went wrong. Okay, and there is something called stack trace. Do you know what is the use of stack trace? The first thing, you need to look for blocked threads. You need to look for waiting threads. You need to looking for threads continuously that are running. Now you are looking for the stack trace. Do you know what is stack trace?
Related to the JVM, means when object is getting created, it is stored on heap, and the respective reference are getting stored in stack. So is it related to the JVM?
No, basically stack trace will give you the complete information of which line of code is the problem. Which method, which class, which function is the problem is what you will understand from the stack trace. Basically, whenever you take multiple thread terms, right, people will ask you what is stack trace and what is the information that you will see in stack trace. Okay, so you need to identify, you need to understand the significance of analyzing the stack trace. Stack trace is something which is going to give you the complete information of the problem of the code, and after that stack trace, you have to look for deadlocks. Occasionally, you may run into deadlock situation, and you will see multiple deadlocks. Can you tell me what is the solution for avoiding deadlock situation? Anyone identified a deadlock, reported it to the dev team, and did you get to know what is the solution for deadlock situation? No idea?
One thing is to look into the code. Other thing, if you increase the thread pool size, there are chances.
Yeah, basically, it depends on the application. I don't say it depends on the application server product. So what you can do is you have to report it to the developer, and there is only one way for this activity. There is only one way to avoid the deadlock situations. The development team has to write the code in a way where deadlocks will never happen. That is the only solution. By looking at the stack trace, you don't unnecessarily terminate, touch any of the thread, any of the object that is part of your application source code. The only way of eliminating thread deadlocks situation is the developers has to write the robust and efficient code for effective performance of the application. There should be no deadlocks happening. So if you have so many things that are your application is not able to handle the load, if you are exhausted with the available threads in the application, it's a serious issue. When your application server is full of threads, the CPU utilization on the server will be extremely high, close or equal to 100%. Then you take a thread dump, and if you can see all the threads are in running state, it could be because of a non-responding backend system, or your application does not have a timeout. Okay, so some application servers leave the parameter called maximum number of threads as dynamic. So if your thread pool setting is 50, based on the number of threads, based on the activity, it can automatically increase the thread pool size. Okay, the application server, it is free to spawn as many threads as possible. This is not a good practice. You always need to have a specific number for a thread limit. And if you go to the thread pool, which is used for web container, it depends upon the application server product. For example, I am working on WebSphere. There is a web container, and there is a thread pool that you can configure. You can increase the thread pool size. So if you have a question like, do I have to configure the number of JDBC connections in the connection pool equal to the number of threads in the application server?
Not exactly.
No. Number of JDBC connections and number of threads do not have 1:1 relationship. Typically, you will have fewer threads than the number of JDBC connections, because the same thread can be reused for several connections. It is not that if you have 10 threads in thread pool, you should have 10 JDBC connections. You understood, right? So number of threads is configurable. And my question is, can I have unlimited threads? That number is
No.
You cannot do that. It is configurable, but you have to ensure that you have an upper limit. I would say 50 threads is a very best practice for any thread pool. Only by doing a load test, different types of performance testing, it will help us to determine the optimal upper limit. We can decide how many number of threads that can be set in a thread pool. You cannot have unlimited threads because it is limited to your hardware. It depends on the software and hardware configuration that is available. It is not a best practice to have application server automatically expand the thread pool size unless you are absolutely sure about what you are trying to achieve with respect to performance testing. Okay, so the last concept is the configuration part. I don't know why I'm not able to open it.
Actually, what was the counter name for setting maximum thread size?
I'll show you because I'm trying to open that. Yes. So you have work managers in WebLogic. So basically, if you go here, right, in the work managers, you can see the minimum threads constraint. You can configure here. You can see the maximum threads constraints. You can see the capacity constraint. You can also see how stuck threads should be detected, what action should be taken if they are occurring. So if you want to ignore that, you can do that. If you want to specify thresholds for this work manager, you can do that. And if something you want to configure from the maximum threads, you have to click on leave and you have to go to some other place to uh, configure all of that. Okay, these are all the parameters. So even if you go to the servers, right? So there are multiple tabs here. You can go to the tuning part to see uh, stuck thread max time, stuck thread time interval, login timeout, SSL timeout. So there are various options. As I don't have admin access to this performance server, I'm not able to open this monitoring tab. But when you open this monitoring tab, under this monitoring tab, you can take a thread dump again from the WebLogic server and WebSphere server. Okay, so you can, if you have a question like how can I kill a hung thread or a stuck thread, first of all, it's very risky for any business to forcefully kill a thread. Okay, if you forcefully kill a thread, what will happen is it will corrupt the data in the database. Okay, so this technically means that you cannot kill a thread in Java, but restarting the JVM is an option. But when you restart the JVM, right, it can terminate other threads that may be doing useful work. You have to understand that every environment is different. If you absolutely know the application you are managing, you're running multiple tests, you can try interrupting stuck threads by some creative ways. That is not anyhow, that is not allowed because we don't even get access to the dedicated performance environment. So if the thread is waiting for a response from a remote service, you can stop that service. That is one way. Okay. When you stop that service that is up and running, most probably your application will receive an exception like socket closed by peer and exit the thread, right? But there is no guarantee. So again, Oracle database has some different mechanisms like thread interrupt, thread dot interrupt that may work in some situations, but you will have to write a program to interrupt a thread, kill a thread. For web application, for WebSphere application server, you can try something called hung thread interrupter tool from IBM AlphaWorks, which can do some experimentation. That's all. So troubleshooting thread issues is extremely, I would not say it is difficult. It can become easier by carefully analyzing the thread dumps. When you don't take a thread dump, if you don't understand what your threads are doing in an application server in your environment, you don't know what is the bottleneck is all about. So to get more familiar with all the thread terms, you have to know little bit of Java. Start reading Java, get some 20 to 25% of the basics of Java. What is thread, what is log, what is monitor, what is synchronization. So if you try to get more familiar with thread terms, and it is more easy for you to analyze them. And as we are all performance engineers, the generic expectation of every customer is that I hired a performance engineer, he can do anything. No. When you have some problem with the application server, the performance engineer has to consult the application server administrator when you have some doubt, which is very sensitive. Okay, you may read so many articles, blogs, forums about or related to threads and thread dump analysis available on the internet. But when you get some good hands-on, analyzing them would give you more knowledge and experience is what I would say. Okay, so that's all for today. thanks all of you for joining, and please understand that this thread dump analysis threads concept will definitely take some 4 to 5 days of sessions, but whatever that is available, whatever that is required for all the performance engineers in common has been identified, and has been explained to all of you. Hope this session is going to help you. It's so nice of you, and nice talking to you all. Thanks again. Thanks for joining, and thanks to Gagan for arranging all the sessions. Thank you.